Hello everyone, thank you for joining us on the eCoreAcademy YouTube page on this video. This YouTube video if you're viewing the YouTube channel, and thank you for watching this video if you're also viewing it through the website eCoreAcademy. So today's topic is going to be presented by me, AJay Raj, through the eCoreAcademy organization, and it's going to be titled Cells of the Epidermis. So that's the topic of today, and exploring the human skin. That's what we're going to mainly focus on, exploring the human skin. It's just our whole entire topic here about the integumentary system, how it revolves mainly around the skin, and how we're going to explore the cellular components of the skin, and specifically the cells of the epidermis. So we're going to break apart this title here. Epidermis right here, you can see that epi is the prefix of dermis, and epi means the outermost and thinnest layer of the skin, and dermis stands for a piece of skin or skin in itself. So it's the outermost and thinnest layer of the skin. So what comes out and makes contact with the exterior world. So let's explore the human skin and specifically the epidermis and the immunizing cells in the epidermis. So the first cell that we come across here are called melanocytes. So as you can see here, cyte is the suffix of melano, which is our prefix. Melano has to do with pigmentation. Melano itself in Greek mythology has to do with dye or coloration, and cyte is a type of cell in which has a immunizing process or some sort of reconstruction or mineral component that helps with building tissue and other cells around it. So here, let's go into the by the book definition right here in my notes here. It says that melanocytes, they are cellular bodies that produce the pigment melanin. So we're going to break apart this definition here. So it says that melanocytes produce the pigment melanin. So melanin specifically is what's produced from the cells. So that's the function of these cells. They strictly produce melanin. Now, melanin has many important functions on its own to the skin and how it affects the surrounding tissue. So melanin itself is what gives us our skin's coloration. So if you have, say, for example, a larger dosage of melanin being produced by your melanocytes, you're most likely going to have a darker skin tone. Say, for example, and vice versa, if you have a less amount of melanocytes and their production is much less, then you're going to have a lighter skin color and less pigmentation. So that's why if you see many genetic diseases such as albinism albinism actually causes the skin to have nearly no pigmentation. So they lack melanocytes in their skin. And that also gives them weaker immunity because melanocytes are not only used for skin pigmentation, but they're also immunizing cells. So what melanocytes do is they actually help us against the harmful rays emitted by the sunlight. So they help us with the exterior world, mainly the sun. So the sun, in some cases, it produces very many important and nutrition chemicals through its rays, such as vitamin D and other important chemicals that our skin needs and our body needs to come into contact with, as well as light in general. However, the sun itself can produce some harmful rays and emit some harmful rays, such as UV radiation. UV radiation can cause skin cancer, and therefore melanocytes, they actually help protect us from such harmful types of skin cancers. So melanocytes, there are two types of different pigmentations that melanocytes can produce. There's eumelanin and melanin. So eumelanin is a lighter form of melanin, and that's found more in people. They're not necessarily contrasting. Everyone has a certain amount, but one's always more dominant. So if you're lighter skin, you have more eumelanin, and if you're darker skin, you have more melanin. Melanin is much darker and richer. That's not to say that lighter skinned people have less immunity. It's just that they're much more susceptible to sunlight if they haven't been exposed to it in heavy amounts already. So, melanocytes help protect us from that. Now, if you look here at this picture here, it's a diagram. It's actually a fairly accurate diagram in this. It's a clip art diagram. And as you can see here, it has many of the major cellular components in this cell, this melanocyte. So you can see here the Golgi apparatus, that is the actual emission in the cell, the nucleus, which is the center of the cell, the command center of the cell, the endoplasmic reticulum, which is basically where the DNA is stored in this cell, and the layer in which is wrapped around and protects the nucleus. You see mitochondria, which are the powerhouse of the cell. They produce energy for the cell to work. And then, of course, the dendrites, which are the little branches on the actual melanocyte, which help produce and secrete melanin through its branches. And also, at the end, these little white items here, they're called melanosomes. They're actually communication fibers, and they help emit and they help communicate with other melanocytes and help communicate with the brain, which keeps the steady level of melanin production. Okay, on to the next one. So here we have keratinocytes. Keratinocytes produce keratin, and here it says that keratin is a tough, insoluble fibrous protein that provides protection and helps contribute to the strength and water resistance displayed by the epidermis, hair, and nails. So that's important here. Keratinocytes, by the definition, simple, they produce keratin as melanocytes produce melanin. So keratin is a tough, insoluble fibrous protein that provides protection and helps contribute to the strength and water resistance displayed by the epidermis, which includes the hair and nails. So it's important to see here that it's an insoluble fibrous protein. That means it does not allow any solvents to pass through it. So that means it's a very tough and sturdy type of protein, and it's actually an essential protein for the skin. And then later on, you see here it says that it is water resistant. It displays water resistance and it helps invigorate the hair and the nails. So, keratinocytes, in layman's terms, produce keratin. And what keratin does for the body is it helps with hair growth from the hair follicles, which are located in the dermis, and it also helps with the nail growth in the nail root. So they help us grow not only longer hairs, but very healthy hairs. And what they also do is they help block up our pores and protect our pores. Not necessarily block them out so that you can't have any breathing room on your skin, but they help to almost net them. So netting means that they protect them from any other bacteria that can seep into your pores, because those are some of the easiest entryways for bacteria and viruses. So they help block them out before they actually enter and breach the epidermis and enter the dermis. But they're produced in the dermis, however, they're found in the epidermis. Although the hair root and the nail root are located in the dermis, they also help with growing the edges of the hair, or the part of the hair that we actually see come out of our skin and through our pores. So that's keratinocytes. Next off, we have our second to last cell, immunizing cell in the epidermis is our Langerhans cells. So our Langerhans cell is a dendritic cell, and dendritic cells are cells that are located within the skin, specifically the epidermis in this case, and they also have some sort of immunizing purpose, but that's a very general term. So what a dendritic cell does is it is a immune response cell. So that means it's directly connected to the central immune system, and therefore the Langerhans cell is one of the most important immunizing cells in the skin. And there are macrophages. Macrophages are basically types of cells that change throughout the course of their lifetime, and they either develop or they diminish in the process of that, and they originate in the red bone marrow. So that's also part of the dendritic definition. They originate within bone, which is also starting with the prefix of osteo. And it's involved in the immune response. So what Langerhans do is they don't necessarily develop the skin, but they help protect the underneath, like the underlayer of the epidermis. So you have the outermost layer, which is called the stratum corneum in the epidermis. But after it breaches the stratum corneum, there's 4 other layers in the epidermis that are also vulnerable, and the entire dermis below that. So what these Langerhans cells do is they're located beneath that outermost stratum corneum of the epidermis. And what they do is if they see any known bacteria, they immediately communicate to the central immune system, which communicates back to them immediately. If it's a known bacteria, they hook onto these bacteria and they basically self-destruct and destroy them. However, if it's a virus or an unknown bacteria, they actually get passed through, and our central immune system within the body actually has to fight that off. And sometimes we get sick because of that, because we don't, our Langerhans cells were not able to fight that. But they're a very important immune system cell, immunizing cell. And I want to go back and look at the diagrams. Just to recap on keratinocytes, that's just a scientific view on a microscope of the keratinocytes. It's very general. This is obviously the nucleus, and this is the outer cell membrane. And yes, now we're on to the next one. Langerhans cells. Langerhans cells are basically very they like to form a net-like structure because with each other because they are very communicative. So every time a actual Langerhans cell is destroyed, another one will always take its place, and that's through communication, constant communication. So they travel together and they bunch up in parts of the skin in which bacteria are plentiful. And then finally, we have our Merkel cells. So Merkel cells are not necessarily part of the immune system. However, it's a part of the immune system connecting with the central nervous system. So this has to do with the sensation of touch. So Merkel cells, by definition, they function in the sensation of touch along with other adjacent tactile discs or receptors. So in the skin is the outermost part of the body in general, the dermis and the epidermis, epidermis being the outermost layer of the skin. So when we come into contact with anything, physical contact with anything in our exterior world, say for example, it's a perturbance like a poke, or you get scabbed, or something happens and roughs up your skin, that's the first place where the central nervous system functions and you actually feel touch. Therefore, you have many different types of receptors. There's 8 main receptors, but Merkel cells are one of the most important because they also help with immunization, and that's the whole idea of today's lesson. So they function with the sensation of touch along with other tactile discs. Tactile discs are basically function in the motion and touch receptors. So they're the same as Merkel cells. So what Merkel cells do is basically they're these little discs. As you can see here, this is the very center of the disc, and basically you have wrapped up different components inside, which are basically like cellular membranes, but they're also like basically they're like sensory receptors. So as soon as that's touched, that vibration, that small vibration that's touched in the epidermis and the skin, these Merkel cells will emit it to the center of the actual cell, and it will make an immediate electro response to the brain. And then it's called an electric pulse type of communication because it's so fast. And within milliseconds, the brain responds back and contacts the motory receptors in the body, and then the Merkel cells have done their job, and then the brain takes over. And say, for example, you have heat, which also creates a certain amount of stretch in the skin, which the Merkel cells will immediately take notice to, and a touch, something like that, that is unnoticed that the brain or the eyes have not seen yet, or the ears have not taken up. Touch will take over, and say, for example, it's an unpleasant feeling and it's starting to hurt. The Merkel cells will take that sensation of touch, transmit it to the brain. The brain will then communicate to the motory receptors. And say, for example, you have a scalding hot pot of water, or someone's starting to nail you right into the skin. It's starting to hurt. The brain will then communicate with the rest of the body to actually move away from that perturbance because say, for example, it's damaging you, it hurts. The Merkel cells have communicated that, and the brain takes action. So these are the 4 main immunizing and important cells of the epidermis, and that'll basically close out our integumentary system unit on the epidermis. And we'll get into the layers of the epidermis later on, as well as the layers of the dermis and the function of the dermis. So that'll be it. Thank you for watching. I hope you guys subscribe to the YouTube channel, and please visit and make an account on our eCoreAcademy website page. And as you can see here, eCoreAcademy, we would heavily appreciate you to continue to support us for more future content, because we love and my sister and I enjoy making these videos for you all. And